Okay, welcome to this video tutorial on using cameras in the water rocket simulator. So a camera is your way of projecting what's happening into the simulation into a view that a user can see, and these cameras are virtual objects, so you can kind of place them anywhere, any direction. You can make them fixed to the ground or you can make them move with the rockets, and it's your way of visualizing what's going on in a creative way that gets across the messages about the design choices you're making and the impacts of these changes on how the simulation behaves and the performance of the rocket. So the default view we're looking at here is a perspective mode camera, and we can find that if we look down here in the hierarchy. There's a item here called cameras, and there's a number of here, but the only one highlighted is this perspective camera, and this is the camera that we're looking at. And if you go to the simulation configuration, in the free flight experiments, this camera is what we're using, and it's got at the moment it's slaved to follow the egg. So this perspective camera moves with the rocket, so the egg's always in the same place on the screen, and that provides a kind of an easy way of getting a close-up of the action, and it's a really good way of just seeing what's going on in detail with the rocket. So just to remind ourselves what that does, so this is a perspective camera, and if you look, actually the egg is staying in the same place on the screen because the camera is tracking it. It's good for seeing the action, but obviously you don't get any idea of space because the camera moves with the vehicle. Okay, so that's the perspective camera, and if we now change this mode to wind tunnel and do update configuration, you'll see here the camera automatically selected by the simulation is the orthographic camera, and this is the one without any perspective. And it just means if you're doing a more sort of sciencey sort of visualization where you want a regular grid in the background, not distorted by perspective, it makes sense to use a orthographic camera. And so when you run this one, you've got a nice regular grid to look at your angles against. So that's automatically selected by the simulation, and for many users that will be completely sufficient just to use those cameras automatically selected by the simulation. But for those that want to dig in a bit deeper and try some more other creative things, there's some other cameras that you can try that you have to select manually. So the first of these we'll look at is the fixed ground camera. So this is over here, and so if we enable that, let's go to the free flight mode so you can see what's going on. And in the scene view, so remember in the scene view, if you get lost, if you double click on something, so let's go to the rocket, if you double click on the rocket it will find that in the scene view. Equally, if we double click on the camera it will find that. So this is our distant view camera, so it's highlighted the transform, and the transform is here. So this transform is minus 18 meters from the center. So the rocket is in the center of the world, and each of these squares is a meter. So this camera is located 18 meters in the negative Z direction. So that's positive Z, negative Z. It's located here. It's 2 meters high, so it's sort of standing on a tripod, and it's looking at rotated at 15 degrees about the x-axis, so 15 degrees about that way, so the camera's up there. So we could move this round by hand if we wanted to, so you can move it along an axis. These squares move it within that plane. You can vary the angle of it you want there, so you can set the camera up roughly how you want it. And okay, so this camera is fixed on the ground looking at, and let's just see what that one does. So a nice distant view, and that enables us to see the whole trajectory. So you can't see the details there, but it's good for showing a user the overall big picture. And if you're comparing different heights for different water fractions, say, you've got the heights written on the screen here, but visually you could show simulations next to each other that showed the different height achieved using different conditions. Okay, the last of the fixed cameras is the one on the launch pad. So this one perhaps not strictly necessary, but if any good Saturn V rocket launch, there's always a famous shot on the launch pad, and this little camera is attached right to the bottom of the rocket, and this will give you your classic shot of the rocket taking off. And for that we always want it in nice slow motion. So there we go, there's our rocket launch with water effects. Anyway, an important shot for the publicity department to show the rocket taking off. So those were our fixed cameras. I'm now going to show you the cameras on board the rocket. So these cameras move with the rocket, so they enable you to get shots from the vehicle. And once again, another kind of classic shot from the from rocketry, showing what's going on from on board the vehicle. So let's disable the launch pad camera, and now if we go up to the launch pad rocket, and then the cameras are attached to the body, there's a direct entry here, onboard cameras grayed out. If we enable those, we can see a couple of views here, and there's two here. There's a down camera which looks down the body towards the ground, and then there's an up camera which is looking up towards the parachute. These camera views are overlaid on top of the other one, so you can see them all going at the same time. If you get into the Unity programming side, you can move the views around. But anyway, this shows an example setup of where you can see multiple cameras at once. So if we run that, see what we get. So we get some nice shots of the vehicle going up and down. Great, so that's about it for the cameras. As I say, for many users, you can just use the default cameras. That'll give you pretty good views of the simulation. Those that want to get in a bit deeper can start using the fixed ground cameras and the onboard cameras to add a bit of variety to your video. Above all, this is all about communicating with your audience, engaging them, trying to get across the points you want from what's going on in the simulation. So have fun, be creative, enjoy yourself creating some interesting videos from your simulations.